Hi everyone, welcome back. So for this video, we're going to discuss about components of forces in space. So we're still in module number 1, which is introductory concepts to forces and force. Okay, so for the previous video, we were able to discuss the horizontal and the vertical component of a force. This time, what if the force is three-dimensional or it is in a space? So if that would be the case, we will be having three components. We have the f of x, the f of y, and the f of z. Okay, the direction of a force F is defined by the coordinates. So the direction of the force F is defined by the coordinates, which is y, z, and x. So the rectangular components of a force are directly proportional to the rectangular components of the distance d separating the 2 points. It can be expressed by f of x. So we have here f of x divided by x is equivalent to f of y. We have here f of y divided by y is equivalent to f of z, f of z divided by z. Or it is simply equivalent to the force divided by the distance. And that is our force multiplier. We're going to use this force multiplier when we are already in our vector notation for dot product and for cross product. Okay, so x, y, and z are components of the distance d between 2 points along the line of action of the force. So to compute for the distant components, subtract the coordinate of the starting point from the final point. So final minus initial. So that would be our equation. So for the magnitude of f, it is simply the square root of fx squared plus fy squared plus fz squared. Okay. Now if we have coordinates and we are given the force multiplier, then it is simply force is equivalent to force multiplier times the square root of x squared plus y squared plus z squared. This should be z squared. Okay. Then for the d, it is the same. D is the distance. Okay. So we have x squared plus y squared plus z squared. Okay. So you have here your force F. Okay. So we have here our force F in a space or in a three-dimensional perspective. So we have here the theta x, the angle with respect to x-axis to the force. We have here theta y, the angle between the y-axis and the force. And we have here theta z, the angle between the force F and the z-axis. So we have the f of x, f of y, and f of z. Okay, so f of x can be solved using f times the cosine of theta x. F of y is equivalent to f cosine of theta y. Then for the z, it is f cosine of theta z. Then from there, we can solve for theta z, theta x, theta y, and theta z. Use the absolute value of the components in determining the direction cosines. To find the third angle once any two have been specified, so pag meron na tayong either kahit sa ano, meron tayong dalawa sa either tatlong ito na angle, then we can now solve for the third angle because cosine squared, cosine theta x squared, cosine theta y squared, cosine theta z squared is simply equivalent to 1. So if one angle is missing, then just equate it to this three, add the three angles, equate it to 1, then we can now solve for our third angle. Okay, so let us now proceed with our example. So determine A, the x, y, and z components of the 450 Newton force. So we have here a 450 Newton force. We need to determine the x, y, and z components. And the angle between the force and the uh, the axis. Okay. So how am I going to relate this three-dimensional force of 450 newtons with respect to the x-axis and with respect to the y-axis and z-axis? So what I'm going to do, since this the point of intersection between the x, the y, and the z-axis is at this point, this is the positive. Therefore, on the other side, it is the negative. So I am going to extend the negative side. Okay. Then from there, I will be getting this force here. So the force here would be, let's say this is the force F. Okay. If I can solve for force F, then I can solve for the angle here. Then I can now solve for the f of x. Then this would be, this is the f of x. Then this is the f of y. And this is the f of z. Okay. So first I need to solve for the value of f. So for the value of f, take note I have an angle here of 45 degrees. So may angle tayo na 45. No, it is 35 degrees. So this is f. This is 450 newtons. So 35 degrees. So what I'm going to use as a function would be cosine. So cosine 35 is equivalent to the value of f over 450 newtons. Cross multiply, f therefore is equivalent to 450 cosine 35. So 450 cosine 35, that is equivalent to 368.62 newtons. Okay, so I now have the value of n. Okay, so take note, for the f of x, this is a 90-degree angle. Okay, so that is a 90-degree angle. So 40 minus 90, that is equivalent to 50. So the angle here is 50 degrees. Okay, so if I am to redraw that, it would look like this. Okay, so this is f, and that is 368.62 newtons. This is f of x, and this is 50 degrees. I can solve for f of x using cosine function. So that would be cosine 50 is equivalent to f of x over 368.62 newtons. Okay, so cross multiply, f of x is equivalent to 368.62 cosine 50 degrees. F of x therefore is equivalent to 236.94 newtons. Okay, then next would be f of y. F of y, I am going to use this triangle. Itong triangle na to yung gagamitin natin. So that is this. So that is f of y. So that is simply a sine function. So sine (35°) is equivalent to Fy over 450 newtons. Cross multiply, Fy is equivalent to 450 sine 35. And that is equivalent to 258.11 newtons. Okay, so for the y, it is positive because it is above the point of origin. For x, it is negative because it is to the right of the point of origin. Then for the z, it is positive because the negative side is at the back. So for z, I am going to use this triangle. Okay, so if I am to redraw that, it would look like this. Okay, so we have an angle of 40 degrees, and this is F. F is 368.62 newtons. And I am to solve for f of z. This is f of z. So again, it is cosine. Cosine 40 degrees is equivalent to f of z over 368.62. Okay, so cross multiply, f of z is equivalent to 368.62 cosine 40 degrees. F of z therefore is equivalent to 282.38 newtons, and that is our final answer for the coordinates. Next would be the angle. Okay, so from our notes for three-dimensional, theta x is equivalent to cosine negative arctangent, that is f of x over f. Then theta y is equivalent to arc cosine f of y over f. Then theta z is equivalent to arc cosine f of z over f. Okay, so solving for theta x is equivalent to arc cosine. What is f of x? F of x is get the absolute value, 236.94 divided by what is the value of f. F therefore is 368.62. Next, theta y is equivalent to arc cosine. You have what is theta y? 258.11 divided by 368.62. And lastly, theta z is equivalent to arc cosine of 282.32 divided by 368.62. Okay, solving for the value, okay, so we have 50 degrees. Next, for theta y, we have 45.56 degrees. Then lastly, we have 282.32. No. There's an error. We should not use the 368 because our force here is 450. And these are the components of 450. No, it is not 368. It should be 450, 450, and 450. Error. That's an error. So let's change the denominator. Calculate. We have 282.32. This is equivalent to 51.14 degrees. Then the other one is 258.11. That is 54.999. That is equivalent to 55 degrees. And lastly, we have 236 0.94, and that is equivalent to 58.23 degrees. Paano ko nasabing may mali? Because if we are to observe here, the angle here, take note, this is also a right triangle. Okay? The angle here is 90, so 90 minus 35 is equivalent to 55 degrees. So that is theta z. So if we are to observe, the angle here is, by observation, the angle here, which is theta z, is 55 degrees. So tama na yung angle natin dito is 55 degrees. That's why nasabi natin kanina na may mali. Okay? So we have here example number 2 from your module. A frame ABC is supported in part by cable DBE. So we have frame ABC and it is being supported by a cable DBE that passes through a frictionless ring at B. So we have here a frictionless at point B. Okay? Knowing that the tension in the cable is 385 newtons. So the tension all throughout this cable is 385 newton. Determine the components of the force exerted by the cable on the support at D. Okay, so we are to determine the X, Y, and Z component exerted by the support at D. So if you are to redraw your free body diagram, it would look like this. Okay, so you have there your force F. Okay, so you have, that is your force F. We have here your 3 other forces. It should be downwards, then here. Okay, so that those are your 3 forces. Okay, so let's first solve for the we are only going to solve for the X, Y, and for the Z. So this time we are going to use our coordinate system. Okay, so for the coordinate, we can recall from our equation that f of x over x is equivalent to f of y over y is equivalent to f of z over z is simply equivalent to f over d, and that is equivalent to force multiplier. Okay, so let us solve for our coordinates first. So how are we going to do that? So for the x, take note, it is from x2 minus x1. So what is our x2? So from our free body diagram, we know that the rope is in tension. So it would look like this. Hihilain yung rope natin from support D. So having this diagram, this is our initial location, and this is our second point of destination. Okay, so on the x-axis, this is my x-axis, x1 is equivalent to 0, while x2 is equivalent to 480. Okay, so 480 minus 0, that is the value of x, and that is 480 mm. Next would be the y. So for the y, it is y2 minus y1. Now for the y, this is the y-axis from a height of 510. So y1 is 510 minus y2. What is y2? From 510, it went down to 0. Okay. Therefore, y is equivalent to negative 510 mm. Next would be z. So we have z2 minus z1. So our z2 is this. So from 0, from 200, from what is our z2, we have 600. From 600 yung z2 natin. 600 minus Z1. What is Z1? It is at 280. Okay, so therefore the answer is 600 minus 280 is equivalent to 320 mm, and that is positive. Okay, so these are our coordinates. Okay. Okay, so in order to solve for the values of fx, fy, and fz, from this equation, we can say that f of x over x is equivalent to f of m. Okay, so cross multiplying, f of x is equivalent to x times f of m. But we do not have the value of f of m. So what I need to do is to solve now the value of f of m. I have a force and I can solve for the distance. Now solving for the distance, d is equivalent to the square root of x squared plus y squared plus z squared. Okay, so substituting the values of x, we have the square root of 480 squared plus negative 510 squared plus 320 squared. Okay, therefore the value of d, or distance d, is equivalent to 770 mm. Then I can now solve for the value of f. Fm rather, F is equivalent to what is 385 newtons. Okay, so we know that as per the problem, it states that it is in tension. But even though if it is not stated, we should be aware that a rope can resist or can carry only can carry forces that are in tension only. It cannot carry forces that are in compression. Okay, so since it is a frictionless pulley, it means that the force, the tensile force at this side is also equivalent to the tensile force at the other side. So it is equivalent all throughout. Okay, therefore our force is 385. So 385 divide, and that is in Newton, divided by 770 mm, and that is equivalent to 0.5 Newton per mm. Okay, so we can now solve for f of x. So f of x, we have the value of x as 480 mm times the f of m, which is 0.5 Newton per mm. Mm will simply cancel out. We will be left with f, and that is equivalent to 480 times 0.5, that is 240 newtons. Okay, is it positive? Yes, because it is pointing to the right. Okay, next would be f of y. So f of y over x is equivalent to f of m, cross multiply. F of y is equivalent to, no, it is y rather. Y f of m. What is the value of y? Y is negative 510. Okay, so negative 510, that is in mm, times the force multiplier, 0.5 Newton per mm. Mm will simply cancel out, and f of y is equivalent to 255. Tama. So 255 Newton, and that is negative because it is pointing downwards. Okay, next would be f of z. So f of z is equivalent to z times f of m. What is the value of z? Z is 320 mm times the f of m of 0.5 Newton per mm. Mm will simply cancel out, and this is equivalent to 160 newtons, and that is F of Z. Is it positive? Yes, it is positive because it is pointing to this side. Okay, and these are the components of your 385 Newton force.